started. Hello, everyone. Thanks for joining us for our talk today, Tank Cleaning Tune-Up, 5 tips to decrease cleaning time and reduce water use. Leading our discussion today will be Geoff Tanner, Spraying Systems Tank Cleaning Engineering Team Lead, and Anthony Wood, our Food and Pharmaceutical Engineering Team Leader. As these two go through each topic, please ask questions in either the chat or the Q&A section. I'll be monitoring and reviewing those, and we'll interrupt the guys so that your questions can be answered live and in person. All right, take it away, Anthony.
Thanks, Mary, for the introduction there. Let's go ahead and jump in to the presentation here. So Geoff, we put together 5 tips based on our experience, yours specifically as a tank cleaning leader in this organization, common factors we consider, common questions that we receive from our customers in an effort to optimize their tank cleaning operation. So before we jump into the detail, just a real quick overview of these 5 tips that we're going to cover. So number 1, make sure you're using the right approach for the job at hand. The second being the equipment you use depends on the residue. Number 3 here, hot water is only necessary some of the time. Impact may be better. Increasing pressure has different consequences to increasing flow rate. And then finally, there may be a better option than your pre-installed product. So we do ask that you ask questions as we go, but we're going to touch only the surface of all 5 of these topics. Please ask questions. Please reach out to us after the webinar as well. We can get to much detail as you want to. But why don't we jump right in, Geoff, to the first tip that you have. Can you provide us a little bit more information on what you mean by tip number 1?
Absolutely. And good morning, everybody. Afternoon to probably some of you. But so what do we mean by the right approach for the job at hand? Well, for tank cleaning applications, you really have to start asking yourself, what are you trying to achieve? And what are your application requirements? Do you have regulatory requirements for 3A sanitary nozzles or food contact materials of construction requirements? There could also be flammability hazards that may require ATEX certified nozzles. Well, then you can also start looking at other questions. If you're looking to upgrade an application, are you intending to use the same fluid delivery system, or are you able to provide higher liquid pressure and flow rate for the application? Or conversely, are you looking to reduce your water and chemical consumption and the resulting waste process? And finally, what would you like to improve from the overall current process? Do you have any major pain points that you would like to eliminate manual labor? What about minimizing the total cycle time? Well, depending on what that pain point is, we can help guide you through the application to make sure that you're using the best approach for the job at hand.
Thanks for that, Geoff. You've listed 6 questions here to consider. I'd like for a second to kind of dive into at least a couple of these in a little bit more detail. One question we do get a lot is around this number 1, sanitary design, either request for it or whether they need it. Can you give us a little bit more in-depth information around this topic?
Certainly. I mentioned 3A sanitary nozzles, and 3A, if you're not familiar with that, is a dairy standard. And we kind of think of that as, or we hold 3A up as the epitome of sanitary design for tank cleaning. That is a completely threadless, completely self-cleaning and certified tank cleaning nozzle, but it's also certified by an external third party. A 3A auditor has come in and looked at the design, look at the manufacturing of that and said, yes, this nozzle is designed and intended for dairy and food applications that require a sanitary nozzle. We can also look at, though, just food contact materials of construction. It may still be a threaded assembly, but everything in there is rated for food contact. And there's a couple of steps in between there for sanitary applications.
Very good. So let's pick another one here. Let's see, maybe number 5. How long does a cleaning cycle take? Can you give a little bit more in depth on how taking the right approach would would be related to cleaning cycle time?
Yeah, the cycle time is really an important thing. And one thing we always have to take into consideration, something we understand, is that tank cleaning is a maintenance process, first and foremost. It is not necessarily the business strategy to be sitting there and cleaning tanks all day long. Some businesses do exactly that, however. But for the most of our customers, tank cleaning is a maintenance and it is part of a scheduled downtime. So the faster you can clean the tank, the faster you can get back into production and the faster your tank can be doing what it really is supposed to be doing. We don't want to be cleaning things all day long. We want to get back into the process. We want to get back into production because that's where your business is.
So Geoff, I imagine you would say that one of the main or one of the criteria here to make sure we're taking the right approach is selection of the equipment itself, which leads right into your tip number 2. So can you give us a little bit more detail into why this is your tip number 2?
Well, every application is really, really different. And trust me when I say that we have worked on a lot of different applications. So there's a few things to consider here. What is inside the vessel that needs to be cleaned out? A residue that is water soluble can be easier to clean out than a high solid content material or something that's even oil based or very difficult or sticky. So how frequent is the cleaning process? Being able to attack a residue quickly before it dries can be essential to a fast and easy cleaning. Imagine the difference between rinsing out fresh tomato paste from a vat compared to something that's compared to dry tomato paste that's been sitting around for a little while, something that would be really dried and very difficult to clean. So those difficult applications may require a high impact tank cleaning nozzle, but there's a lot of other different factors still. What is the size of the tank? Even a residue that's relatively easy to clean may require a high impact nozzle if that tank is large enough. Simply stated, if only simply to spray the entire tank and provide full coverage. But then not only is the size of the tank a factor, but what else is inside it? Do you have baffles? Do you have agitators or mixers or even heating and cooling coils inside the vessel that can create blind spots or shadowing in the coverage? So being able to get past those blind spots or those obstructions to be able to clean behind them is very important. And finally, another application question is, what is your definition of clean? Are you okay with a minor residue remaining behind, or do you require a completely sanitized application where you have to do swab tests to make sure you have no contamination batch to batch?
So Geoff, we have a common question that we receive a lot of the time, which is, how have you solved this problem in the past? Or if somebody, you mentioned the tomato paste example is one. Can you get a little bit more in depth on why, whether we solved it for one customer, even if another one has a similar residue or product that they're making, that their solution might be different?
Well, it depends on how you're cleaning the tanks. And as I said, kind of the frequency of cleaning. Some customers aren't able to attack the cleaning process immediately. And the nature of their process is that it just has to sit for a little while. And in that case, we sometimes talk about the actual impact, and we can get into that a little bit. And then I think it's in tips 3 and 4, impact and just being able to really blast the hell out of something sometimes. But we work with customers a lot on the overall process, not only understanding how to clean stuff out, but how to try to optimize the overall process and do things just a little bit better to save some time, save some money, and do things just. Sometimes it's doing more with less. Sometimes it's just overall optimization.
Right. Thank you for that, Geoff. So that's a good segue too, because we're talking about residues here, and you've mentioned tank size as well, but then you just mentioned impact about blasting a surface, which leads right into tip number 3, which is the comparison and relationship between heating water or your solution you're using to clean and impact itself. Can you give a little bit more in depth? I think there's more explanation needed about how these relate to each other.
Yeah, the next couple of slides, this slide and the next one, are really important and sometimes very difficult to understand. So impact is cleaning. The harder the water hits the target, the faster and better it can remove the residue. The question is, how hard is enough? But it's also difficult to understand because impact is prohibitively difficult to actually quantify to a number. However, it is highly dependent on a lot of factors we can talk about. We're going to mention flow rate and water pressure. And I saw one question pop up real quick. GPM is gallons per minute. And that is something that the overall flow rate, and we're going to get into that question. We will try to answer that in just a few minutes. Great question. Impact is difficult to quantify, and it is very dependent on such things as flow rate and liquid pressure, but also how large is the tank? What is the spray distance from your tank cleaning nozzle to the actual target, and the angle of attack? When that tank cleaning nozzle is hitting the wall square on, it has a higher impact than when it is at an obtuse angle or something along those lines. Generally speaking, the more impact we can provide, the better. However, is it enough? Or would using water and chemistry be better for the application? We've had a lot of customers look at these questions, and sometimes you can never answer them until you actually try it and are able to put a tank cleaning nozzle in the process and give it a shot. We've had customers looking at expanding. We had one customer in particular that I think we have a case study on later that we can talk about. We had a customer looking at, they were expanding their overall production process, and they were building new tanks, and they were on the verge of spending $1 million on a hot water supply system just for cleaning those tanks. And we worked with them to improve the cleaning process itself, going from a medium impact nozzles to some high impact nozzles that eliminated the need for the hot water system. It was literally $1 million saving investment that they didn't have to go through. So huge benefit to the customer by increasing their overall impact, by not having to use hot water. However, sometimes, as we can talk about, heated water and chemistry is absolutely critical or absolutely important to the process.
Yeah, so Geoff, you just gave a really good example where a customer saved a lot in a potential investment that they didn't need to make. Certainly have some other people that are currently heating now that have the equipment they need to heat, but there's some energy savings, utility savings, efficiency savings, and not having to heat if they don't have to. Do you have any suggestions on how they might go about, if they're heating now, maybe eliminating or reducing the amount of heated solution they use?
It really is application dependent. It's something we can definitely work with any customer on, trying to optimize the overall process. Unfortunately, there's very few applications with it's a one size fits all. Every application does have its own small idiosyncrasies and application demands. So Anthony, I understand the question, but it's a really difficult question to try to answer. So I would love to be able to say, yes, we can always eliminate hot water, or we can always minimize the amount of water consumption or chemical consumption that's being used. But sometimes it really is necessary. We just have to figure out what is the requirement for the application.
Sure. Yeah, unfortunately, there's not a one size fits all answer to some of these questions, kind of digging into the detail of the application itself.
Yeah. Well, that's why we're here, though, to help understand those applications.
Right, exactly. So somebody mentioned, Geoff, you said as well, that asked a question about gallons per minute, kind of leads well into the next question, which relates our pressure and flows and chemistry on top of that even. So our tip number 4 here, can you give us a rundown of this one as well?
Yeah, absolutely. So for number 4 here, what we're talking about is the liquid pressure and how impact can change depending on liquid pressure and flow. So the liquid pressure and flow really affects the impact of the walls, and that can be a little impact on the walls, and that can be a little counterintuitive. So doubling the liquid supply pressure, that actually only increases your total impact by 40%. However, if you double your flow rate, that actually increases the total impact by 100%. Doubling the flow rate doubles your total theoretical impact. Not only that, however, but higher flow rates actually improve the throw distance of the tank cleaning nozzle for larger tanks. The solid stream from the nozzle has better stream integrity and is less prone to breakup at further distances away from the nozzle. Conversely, higher liquid pressures can actually reduce the effective throw distance because the increased turbulence inside the nozzle. That basically leads to higher break or more rapid breakup of that liquid stream. So it really does not make sense sometimes. You would think liquid pressure equals theoretical impact. And that's really not always the case. Flow rate does tend to be more important for maximizing that impact and maximizing that cleaning effectiveness. However, the chemistry being used for cleaning can be more important than any of this for your application. Some residues simply require a little assistance to start breaking down or dissolving. We have some customers that really just apply a pre-rinsing agent onto the residue and then let it sit for a little while. And that helps to let the chemistry do its job before completing the full cleaning cycle, before coming back and doing an actual cleaning process. The combination of chemistry, flow rate, and pressure really is highly dependent on the application. As we just said a few minutes ago, there is no one-size-fits-all solution to any application. But we are really happy to help start address these questions for you and work through the application.
Yeah, Geoff, that's actually, sorry. That's actually a good segue into an example that someone just brought up. So they're looking at applying a degreaser to tank walls with minimal chemicals, but enough pressure to hit all sides of the tank. In this situation, he's thinking low flow and high pressure would be preferable, but this is applying a product for softening dried on or sticky residues. So in this example, is maybe increasing flow rate better than increasing pressure?
Yes and no. That's a great question. Spraying a degreaser is really actually kind of goes into that one example that I said, is putting that degreaser onto the tank with minimal chemistry, reducing your overall flow rate, and applying it out there to let it start doing its job, to let it start doing some dissolving of the grease or the oil, whatever the residue is. You might have to sometimes look at two applications, one to do a very light rinsing and another coming back and doing a high impact to actually move it along. It really depends on how much that degreaser, how functional that degreaser is in providing that breakdown or providing a preliminary breakdown. It could be a combination of both, being able to put that degreaser on and then coming back with a light rinse to simply remove it, or you might still have to have some impact and flow. Depends on the effectivity of the degreaser, quite honestly. That is a great question.
A really great question too. And another thing I'd add, Geoff, to your good explanation is, another factor is how thick is that residue on the surface of the wall? How long has it been there to harden? And that'll help determine the best solution as well.
And also the size of the tank. We talk about that as well, is how much of a throw distance do you have to be able to get to the other end? And the shape of the tank. Is it an over-the-road tanker truck where you have those end caps can be 30, 40 feet away? And looking at the orientation of the nozzle to be able to target the end caps as well, either rail car or over-the-road tanker truck.
Any more questions, Mary?
Yeah, I think this one actually leads really well into tip 5. It's kind of a few questions in one. So do you typically determine the spray device selection and temperature requirements through practical testing, running cleaning cycles on existing equipment and performing swab tests to confirm success? Is there any way to do this prior to building the equipment and putting it into service? So I'll just kind of go into tip 5 with that one.
Oh, that is a great question, Dan. So let me go through tip number 5 first, then we'll come back and we'll try to address your question. So it is difficult, really, if not impossible, for the manufacturer of the tank, or even yourself, to predict how you will be using a tank and what the demands of that application will be over time. So let me ask you all a question. Think about the tanks in your facility right now. How old are they? When were they originally installed? And in that amount of time, has your production process changed since then? The ingredients you're using, the cleaning process you have, or many other factors may be different from the original specifications from when that tank was built or when those tank cleaning nozzles were originally designed and put in. So is the CIP tank cleaning nozzle still doing a good job for your new application? When your production process changes, you can't forget to also evaluate the overall cleaning process. So saying that, and then going back to Dan's question, how do we then figure out what the best optimal process is for a new application or for the new process? We can start working with customers on doing some practical testing in their process or in their facility, or we can just basically go through the application and say, based on historical experience on something similar, this is what we suggest. But there's always the best way to do it is to try it, is to go through, get the tank cleaning nozzle in your process and give it a shot. Just give it a try. As for your one of your kind of sub questions, Dan, you mentioned running the cleaning cycle on existing equipment and performing a swab test to confirm this. To confirm the success. That goes back to my previous question actually for you is, what is your determination of clean? If you require a swab test, yeah, that's basically what you have to do, is try it, do the testing, do the swab evaluation, or do an inspection, riboflavin or whatever it ended up being your inspection process is, to confirm that success. Sometimes it's just a visual inspection though. So we can definitely start helping everybody on trying to optimize that process based on some experience that we have though.
Yeah, Geoff, there's another factor I'd like you to dive into a little bit, which is you could purchase a tank that has CIP in it that's working perfectly the day you bought it, but how does wear over time of that equipment play into the effectiveness of the cleaning process?
Yeah, the long-term use of the nozzle, tank cleaning nozzles, especially nozzles that rotate around in either single or dual axis rotations, they do have wear components. Bushings, bearings, O-rings, seals, they will not last forever, unfortunately. So you do have to have some sort of long-term maintenance process and procedure. And that really does depend on how frequently you use it. A lot of nozzles, tank cleaning nozzles, will last for several hundreds of hours, if not longer, with no maintenance. Some units, depending on the application, if you have high solid content, do you have chemistry issues where you could have degradation of your seals and O-rings, would that require a more frequent maintenance process? So maintenance of the nozzles is always important. You have to take into account. They don't last forever, and you do need to understand that.
Yeah, and then the orifice itself, the chemistry or heated waters coming out, as that wears, we just talked about the relationship of pressure and flow and impact. As that wears, it's not going to spray the same over time. So that's another factor to consider.
That is true. Absolutely.
Thanks, Geoff. One other thing I would add as we're kind of wrapping up the final tip here is most of the customers that we're working with, obviously they're finding good ways to get their tanks clean now. It's not like they're putting dirty tanks or bacteria trapped tanks back into service. But just because you're doing it now doesn't mean there isn't a way to improve on that efficiency. Cleaning it faster, getting it back into production faster, using less energy and chemistry, being more sustainable, those kinds of things. So we'd be happy to, of course, to walk through anybody's application process to look for potential efficiencies. But we'll move on from this last tip unless we have other questions, Mary. And Geoff, those 5 tips you kind of put together, you've also listed here some real world examples of taking those tips and resulting in drastic improvements to customers that would take those into consideration. Could you pick one or two of these and give us some background?
Yeah, well, we already kind of talked about that first one where it was a personal care brand that was expanding their overall process, and they were looking at a $1 million investment that were able to help prevent them going through and paying all that investment up forward. So we have a lot of different customer applications or customer examples. And sometimes it's simply about looking at what those pain points are. So I think we actually wanted to put up a poll for everybody that's on here is, what are some of your pain points? What are your what's the difficulty you have currently with your existing process? And if you can answer some of these questions, I'd like to go through it in just a minute. As we're doing that, there's a couple other examples I wanted to talk about in that some of those pain points, it's always fun to kind of work with the customers in what those difficulties are. Is it simply the waste water consumption and looking at minimizing your overall cycle time to prevent to minimize that waste? And how do you dispose of that waste? There is always a cost to that too. And sometimes that can be very, very expensive to simply dispose of a waste product. But then it's also the overall cycle time and getting the production back into, getting the tank back into, getting the tank back into production so you can start doing your process again. Do we have the results, Mary?
Yeah, a few people are still answering, so
okay.
Maybe go through one more example.
Sure. So trying to skim through these and remember all the applications we've had. So one of the things that we looked at is a paper mill. They reduced, which is example number 4 here, they reduced their overall water consumption by 50% by using a new tank cleaning process. Basically what we did with them is they were essentially using a low impact process, tank cleaning nozzle, at a very high flow rate in order to get enough rinsing application or rinsing impact in their mill process. And so we worked with them to go reduce the overall number of nozzles, tank cleaning nozzles, and increase the individual nozzle flow rate with higher impact and higher throw distance. So the overall total consumption was reduced by half. It was a great application, actually.
Mary, do you think it's possible we can make the details of these and other case studies available to people that have attended?
Yeah, absolutely. I'll put the link in the chat so that everybody can access it. Yeah.
Read the details if you'd like on your own time. I know everybody's time is valuable here. So
yeah, and I'll share the results of this poll too while you guys are talking through that.
Excellent. Oh, water consumption is by far the highest. Yes, that's usually a very big conversational point for us and our customers, is minimizing that time to clean is the other big one, and the overall water consumption. So a couple said other, but they didn't say what it was. So, okay. Well, if you have any other specific questions, or if you want to help us walk through I see Eric actually. The pain point is oil-based. Okay, so removing that oil-based latex paint. Yeah, and that really goes back to kind of what we said before with an oil degreaser, in providing that, using some chemistry to help do that, or a little bit of hot water can go a long way sometimes.
So I add to this, Geoff, too, the number one answer being water consumption. We've worked with a lot of customers in the past where they have decided early on to go with a more economical choice up front, let's say a stationary spray ball, because it gets them a CIP unit quickly and inexpensively. But we can help with the ROIs on looking at more expensive rotary units that are going to have higher impact and use less overall flow to get the tank cleaned. So if your pain point is water consumption, there are tips and tricks we can help you with to optimize and reduce your usage there.
Yeah, you mentioned static spray balls, and static spray balls definitely have application. They're certainly advantageous for a lot of different applications. But we do have some customers that use static spray balls or low impact rinsing nozzles, and they have to use them for 30, 40 an hour, 30, 40 minutes, or even an hour in order to provide enough actual cleaning to get the process complete. Well, 25 gallons a minute over an hour really does add up. One thing that we've had worked with a lot of customers on is, okay, let's bump up that instantaneous flow rate from 25 gallons a minute or 50 gallons a minute to something that's a lot higher. And your overall flow rate, though, your overall water consumption will decrease because you can do your process faster. Even though you're using more water at that moment in time, your overall water consumption really can have significant savings because you can do things faster.
Awesome.
Good addition to that, Geoff, for sure.
Yeah, that was perfect. So I have one question coming in from Phil, and then we've got another one from Dan. So will these solutions that you guys are suggesting, can you guys talk through some examples of maybe times that you've eliminated manual cleaning for people?
Manual cleaning is always a difficult thing to try to quantify. We have had some customers where they are doing confined space entry even, and they're climbing down into a tank, and we're able to work with them to, if not completely eliminate it, minimize it to an inspection process instead. So putting in a high impact tank cleaning nozzle to be able to minimize that amount of scraping. We had one customer, I don't think it was one of the case studies that we showed, but it was a spray dry tower, and they had a really high protein product that they were spray drying. And it was a large tower. I think it was 25, 30 feet in diameter. And they were sending 2 people into the tank to literally scrape the walls out. And we put in 2 high impact tank cleaning nozzles that completely eliminated the manual process. Not only did it eliminate the manual process, but it actually allowed them to get their production back into and get their production process going faster. If I remember the numbers right, they actually saved 24 hours a month in cleaning time. So they increased their production by 24 hours a month, which is a huge amount of time for somebody in a spray dry industry or pretty much any process. It was a huge advantage for them.
I can give some examples here too. Of course, mine are going to be food related, being the food team leader with our organization, but over the road tanker trucks that are hauling milk, we've, instead of sending people into confined space, adding a tank cleaner that drops in on the manway to automate that process, to eliminate the manual process. A couple others, spiral freezers. Some think with the temperatures that it goes down to, you can't keep a CIP unit inside those. And conversely, in ovens that you think it's too hot for the CIP rotary nozzles to handle the temperature of the oven, but we have solutions for those. Doesn't always 100% eliminate the manual process, but if we can reduce it significantly, it's big improvement. Those resources can be reallocated somewhere else in your facility. So those are 3. We can give you plenty more if you have specifics of your type of operation. We'll try to get you some specifics around those, but those are a few.
And for those who haven't seen it, Mary did post a link in the comments for the case study examples that we've talked about, and a lot of others. We have a lot of different case studies available on our website that she sent the link for.
Yeah, I'll send that in the post meeting wrap up where I send out the recording too, just so you guys have those resources. So we have a follow-up question from Dan. What is your recommended method for confirming the health of a cleaning device? Do you monitor supply line flow and pressure from cycle to cycle? Do any of the rotary devices have technology to monitor or confirm rotation?
Dan, that's a great question. Yes and no is kind of the answer to some of this. Confirming the health of a tank cleaning nozzle sometimes is as simple as doing just a visual inspection on whether or not the tank is still clean. And that depends on your process, quite honestly, is how sensitive is your process to it. If you need online monitoring, we are working on some solutions to this, but monitoring the supply line pressure and flow rate cycle to cycle is a really good way to start doing that. If you start seeing the pressure decrease or the flow increase, that could indicate certainly that something may be wrong with the overall process. What that won't tell you, though, is whether or not the unit is rotating or not. So we are working on some solutions to this, and we can probably talk about that a little bit offline, a little bit more, a little bit better.
Yeah, Dan, let me add just another note from my perspective as well. We have usually customers we work with our product often are in one of two camps as far as rebuilding units. One being they've built a maintenance program that they know they're going to rebuild these every 12 months, and they just do that process to ensure that it doesn't eventually break down on them. And the other would be allow your visual inspection and your ATP swab testing or whatever other QA you're using to validate that it's clean. If it doesn't clean there, you have the spare on a shelf that you can pop in immediately. You're cleaning again while you rebuild the one that needs rebuilding. So a couple different techniques. It's personal preference.
And we do, speaking of that, Anthony, we do work with customers a lot on maintenance procedures and installing a process for rotating units out. If you have 5 tanks, you have 6 units. You take one out on a regular basis, you could send it back to us for maintenance, rebuild, and validation, or you could do it yourself. But having a rotation of units through your tanks is always a great maintenance process.
Awesome. We have a couple more coming in. I don't know if these are related or not, so I'll just ask them at the same time and I'll let you guys decide.
Sure.
Does your company use steam to clean containers? And if so, what nozzles do they use? And then we have kind of a similar question. Have you used spray nozzles to do dry cleaning with compressed air?
Oh, those are good questions. So I'm going to actually answer the last one first. So we have used a couple of tank cleaning nozzles with compressed air. Now you have to be careful with this because a lot of the tank cleaning units, especially almost anything that rotates, uses the liquid flow rate or the mass flow rate in more particular to actually drive the rotation. Well, since air doesn't have the same mass that liquid or water does, most rotating tank cleaning nozzles simply won't work with compressed air. We do have a couple, though, however, that are motor-driven tank cleaning nozzles. In particular, the AA190, and there's a couple of versions of that. That will work with compressed air. Now, the caveat to that is compressed air does not have the same amount, because of the mass differences still, does not have the same throw distance that water does. So if you're looking at a larger vessel, anything more than really 6, 8 feet in diameter on the maximum side, using compressed air through a tank cleaning nozzle probably isn't going to be the most effective use of the tank cleaning nozzle. There are other ways we can start looking at that with air cannons, with air blowers that would have higher flow rates and provide a little bit more more designed application of air through the tank. The other question was using the steam, right? Right, Mary, was that question?
Yep, that was it.
Okay.
Did you use steam to clean it? And if so, what nozzles do you typically use?
We have had customers use steam to clean the tanks. We don't ourselves have products that can handle steam directly. We do have some high temperature units, in particular one that can handle up to a couple hundred degree Fahrenheit processed liquid that is not necessarily for steam, because again, you have the same risk with the mass flow rate. Steam is not liquid. Steam is really, it is a gas, so it doesn't have the same mass flow, so it won't drive a tank cleaning unit around. Using steam to heat the processed liquid using, what we do offer, or one of the things we do work with customers on, is using a steam injector. So you can take your steam, you can take your city water and mix them together in the steam injector and create high pressure, high temperature water that can do a much better job in doing the cleaning process than necessarily steam can.
The thing I'll add here is, in case this question is about cleaning in general of a plant and not necessarily just tank cleaning, if you're trying to clean a conveyor, for example, just through a series of nozzles, we can talk, offline about the specific types we can use for steam. But Geoff answered it well for the tank cleaning specific products and applications. So,
well, I am the tank cleaning business leader, so
yeah.
Yeah, that's perfect. Okay, so we've got one more. Can we safely assume then that efficiency of cleaning and water consumption can both be reduced with spray nozzle cleaning?
Water reduction can be used, efficiency can be improved. Yes. Going from a manual process to using tank cleaning nozzles, yes, that's safe to say.
Yeah, I agree.
Vast majority, it'd be exceptions to the rule, but that would be the main rule.
Yeah, do you guys ever encounter times when people are not using a spray nozzle necessarily to clean a tank? So maybe they're just using something really random?
Yeah.
One thing we often see is fill and drain. So literally filling the entire tank up, letting it soak, sometimes using the agitator to provide some level of mechanical action, and then draining it out. It takes a ton of time, and it uses a massive amount of water and chemistry and just energy. We've actually seen customers fill it up and then boil the vessel. That's a huge amount of energy. It's a huge amount of waste, quite honestly. Going from a fill and drain to a high impact tank cleaning nozzle will save a huge amount of energy, water, and just time.
So fill and drain and then manually scrubbing are the two manual processes that we see that are not using, or processes where they're not using tank cleaning units that we help to improve on. Yes.
Perfect. All right. If no one else has any questions, start wrapping it up here.
Yeah, just a real quick wrap up of the 5 tips that we had. So I'll repeat those again, and then we again welcome anytime offline going further in depth in any of these. But we covered to make sure you're using the right approach for the job at hand. The equipment you use depends on the residue and the tank size, as we learned from Geoff when we covered that. Hot water is only necessary on some of the time. Impact may be better, and how chemistry is important as well. And increasing pressure has different consequence to increasing the flow rate. We're talking about how that relates to the impact force and how hard it's hitting and how far it's throwing of the nozzles that are being used. And there may be a better option than your pre-installed product. Again, tank manufacturer probably sized a good product for that, but they're not going to know necessarily the changes you've made over the years in your process or how worn that product has gotten over time. So opportunity again for us to help out with efficiency and optimization. So that'll wrap us up if we have no other questions.
Yeah, that's great. I'll give everybody like maybe a minute or so while we wrap up. So I will send out thank yous. It will have the recording here. It will also have links to our resources page, so any tank cleaning resources, and then tank cleaning product page in case you just want to review some of the products that Geoff was talking about: motor driven, fluid driven, spray ball, etc. So thank you guys. Thank you, Anthony. Thank you, Geoff. You guys did a great job. If you guys have any other questions, please contact any of us. It's just our first last name @spray.com. So we'll be happy to answer any questions. Thanks, everyone.
Thank you.
Thank you all.